Hi everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week, we're chatting about the recent Cloudflare outage that impacted multiple services, including X, OpenAI, and Anthropic. We'll also cover the global outage trends we're seeing. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. Cloudflare experienced a recent outage that impacted many of the web's leading companies. What did you observe here, Mike?
So starting around 11:30 UTC, we started to observe services that were using Cloudflare. They began to experience these failures. So what we started to see initially was these HTTP 500 responses. So this is an internal server error, and it tells us that we're effectively seeing a connection to the front end, and we're getting some signal back. We actually couldn't get to the other end. The commonality across here was that they were all using Cloudflare, so they're all terminating that. So we could see these connections coming across different service providers, going to different services, different applications. But again, they were all effectively using Cloudflare or using services from Cloudflare. And then we were seeing these 500 errors come back from there. So Cloudflare identified the root cause as a database permission. And it was a change that actually made to a configuration file. This file is generated every 5 minutes. And what it does, it effectively gives the rules for the bot management system. So what happened was the courier that's producing this file didn't filter properly. So after the change was made, what happened then was this file doubled in size. So when we normally have around 60 features in this file, it actually grew to over 200. The trouble was this oversized file then was loaded into Cloudflare's proxies. What happened is it exceeded the hard-coded limit of 200 features and actually caused the proxy or the service to actually crash there themselves. Cloudflare identified this root cause, as I say, and actually deployed a fix. This fix was deployed around 14:30 UTC. But because of the distributed nature of the way that Cloudflare's network set up, or Cloudflare's environment set up, meant that we had some sort of longer tail recovery coming down as this configuration propagated globally.
Tell us more about why a single configuration change has the potential to trigger a major outage.
So we're making a configuration change. Essentially, we could be altering one particular system, but what happened in this case, it was something that was needed across the control plane. So it was actually a change that was sort of right across all the systems themselves. So anything that was actually utilizing this bot management system in terms of the Cloudflare environment was actually going to be impacted. And this is what happens with these configuration changes. When you actually make one, you're not making it in isolation. You make a configuration change, which could either trigger some latent condition, or it could be some sort of roll-on effect that then, as I said, sort of propagates right across the environment. If we're making one configuration change to one element, potentially we don't have this increased radius of impact. But typically what happens is you do have this cascading effects. Now, if you actually looked back through sort of outages we've seen in 2025, we started to see these configuration errors and impacting the application performance themselves, or the application availability effectively, because we're making changes that impact the whole of the infrastructure, because we're making them at that service level, or that, in this case, the infrastructure level, which again is going to propagate globally around the area.
When outages happen, it's important to quickly determine exactly where in your service delivery chain it's occurring. What are some strategies ITOps teams can use to diagnose the fault domain?
So the key thing from an outage perspective is understanding who's responsible or where that fault domain is. Because if I can actually understand within an entire service delivery chain, and remembering we have these different service providers, we have different dependencies and different systems involved, all interacting together, I need to be able to understand specifically where that fault domain is. Because what that does, it allows me then to understand what steps I need to take. In this case specifically, the first thing we can actually do is we can identify that we had no systemic network issue. So I'm actually looking at that. I didn't see any performance degradation across the network beyond the fact I actually couldn't get to the service. But what was more critical to that was I actually saw this HTTP 500 error coming back. That was the area I could identify. Now, if I'm looking at this then across my service delivery, what I'm looking for is this common aggregation point. If I'm an enterprise organization, I'm running this system or SaaS service, is it impacting multiple services? So unlikely that it's going to be every service has had exactly the same fault. Now, it could be, do they have a common infrastructure? Are they all running on the same cloud provider? Are they all hosting the same environment? Are we using a common CDN? It's looking for those types of things there. if I'm using multiple CDNs, is it all of them that are impacted or is it one that's impacted? Because again, all these are going to specifically tell me what's happening. In this case, what we actually started to see was these 500 errors. So we know it's coming from there. The commonality was it was all services that were utilizing Cloudflare. So we can actually tie it down. Interestingly enough, again, this was a global pattern. There was no sort of regions impacted. Because if you think back to some of the other outages, if we've had some local data center failure or some sort of power issue or a chiller tripping something out, effectively we're impacting the workloads within that one area itself. So I see a regional impact itself. So again, looking for all these patterns helps me understand specifically what's going on.
With outages that impact distributed systems, such as this Cloudflare incident, recovery often takes time. Why is that the case?
Cloudflare operated and actually found out what the issue was. So once it identified it, they actually stopped generating these bad configuration files, and then they deployed the fix. This was around 1430 UTC, but the full recovery, or when they declared it recovered, was around 1710 UTC. This extended recovery window sort of shows the complexity of restoring these distributed systems. So we're not dealing with this where I can flick the power switch back on and all the power in my house comes back on. It's this propagation effect. So once we've had this fix, remember this file was being pushed out and it was being refreshed every 5 minutes. I have to go and actually sort of propagate around my entire environment before it can actually sort of take place. That's why we start to see this long tail of recovery coming through till effectively all services were finally restored. And it also might have taken some action on the user side themselves. They might have had to reset things, restart things. And the way the proxies were actually failing as well was that it had to go through and sort of restart them. So we have to not only apply this fix, we then have to restart the proxy and we have to wait for all of this system to converge and propagate again. So again, this is why you have this sort of long tail of recovery coming through.
Some companies responded to Cloudflare's outage by redirecting their traffic away from Cloudflare. Deciding when to make a switch like that is a difficult balancing act for companies. Explain some of the factors.
When we say redirecting their traffic, what they did, the organizations had the capability to do this. They actually changed their DNS records. So if we think about what happens normally, the DNS records, if I'm going to acme.com, the DNS records will be owned and pointing to Cloudflare. So that's how my traffic is routed and directed to Cloudflare. And then Cloudflare does the processing and it passes it on to the origin infrastructure effectively. What they did in this situation was the organizations that could, they altered their records. What meant was they then had different IP addresses, and those IP addresses were effectively their own orgs. So they then came back to their own autonomous system number. So rather than when we're looking at the path, we're seeing things terminated to Cloudflare. At this point, we then saw them terminating at the organization's autonomous system number instead. Nothing had changed from a user perspective because the name itself, acme.com, was still resolving exactly the same. And I could actually still then sort of pass through. But what I'd effectively done, I directed my traffic effectively to that domain as opposed to going through Cloudflare to get to that domain itself. This is called DNS failover. And when I need to make that decision, first of all, I need to identify that this problem is occurring. So I need to identify this is where it was. So there's this period of time. Then they also need to make the decision of when do I take action? They actually went at various times. They were all taking different times before they actually made this change to re-advertise their records. What that then meant was that some of them might have been waiting for a status update, or some of them might have been going, we have this situation where we identified the problem as Cloudflare. They put it on their status page. They actually said that. And then these organizations, so they've gone through their own situation and said, right, we need to put in our mitigation plan. The ones that effectively acted quickly had probably planned for this, and they had this DNS failover sort of taking place when we have this condition, and they had timers set in place to actually do that. Others that maybe took a little bit longer, they thought something's going on here. We don't think they're going to get it resolved. What we're going to do at this point is we're going to issue this. We have the capability to do this. We've identified the fault domain, and we're going to do this workaround, which allows us then to route our traffic directly into our own origin domain. Some organizations didn't have the capability of actually making that change, altering their records, or they might have said, we're just going to sit it out because they've identified the issue. We know we're going to come back online soon. We're just going to sit and actually let that go.
It must be tough to decide precisely when you're going to enact your DNS failover if you've got that capability.
When you actually make that decision, it really comes on sort of working out, well, one, can we do it? We've identified the fault domain. Our mitigation plan is to do this. Can we do it at all? And then after that is what's effectively the cost to us to not make this change? Is it easier for us to wait? Because there's also a propagation delay when they actually do this change. So if it's going to come back on with the next half hour, because we've identified it, we think this is what's going to happen, then we're happy just to sit and wait. Do nothing is an option for some organizations, or it's going to cost us too much money. We would rather bypass the situation. And there is costs involved in this, not just the financial cost, but also from a performance perspective. So these organizations that switch, because they'd moved effectively from this edge caching, this CDN environment, to effectively a load balancing scenario, which operates on healthy instances from a load perspective as opposed to what's closest instance to you, they would have had a penalty in terms of the latency that they'd have actually experienced on there. So it's weighing up all those types of things at what point they make that decision.
It seems like cloud outages such as the Cloudflare incident are becoming more frequent. Is that true?
We've seen a batch of them recently. So if you think about sort of the outages we've had over the past couple of months, we've seen this batch of instances, which gives you the impression that they're happening more frequently. But that's not necessarily true. We haven't, in fact, seen an increase in frequency. What we have seen an increase in is the impact of these. Because we're talking about configuration changes or issues that have a global impact, or we're looking at a common service, we're thinking about the services that we're using from these organizations. We have these various systems that come in place, and it's like these best of breed solutions we actually need. It's more efficient for us to actually utilize a service from Cloudflare, for example. And there's more reliance on these third-party dependencies, as it were, to deliver our services themselves. So when they do have an issue, we have this twofold problem. One, we have these issues that are taking place at the configuration level. So we then have this large propagation effect, which sort of has this global impact. But then also because we have these organizations relying on these third parties to deliver these services, it then also has impact across multiple services, as opposed to if I was hosting it in my own environment, it's only that one service is going to be impacted. So it's this compound impact you have. You have these aggregation points from a service delivery perspective, as well as this compound of the configuration for this global distributed environment where this service is delivered.
What can ITOps teams do to mitigate the impact of cloud outages like these?
So you can't actually control the third-party services, but you can prepare for them. Understand your dependencies. So we talk about mapping your inventory of your dependencies and those. But this isn't just your first order dependencies. So, the services you directly use. But try and understand those nested dependencies. Understand how your service delivery chain works. If you can do this, then you start to be able to have that mitigation plan in place. As I said, that mitigation plan, like business continuity plan, allows you to sort of act quickly when this situation occurs because you identify where the problem is. And you can also then start building redundancy or resilience into these environments. And you can actually weigh up those costs. Because you understand that service delivery chain with all those nested dependencies, you say, if we have an issue here, what can we do about it? And do we have to do something about it? Is it therefore then cheaper for us to, for example, utilize another third party to provide that same service? And we split our eggs into two baskets, as it were. So we can effectively have sort of this distributed environment there themselves. Once we actually do that, we've actually know this, we've mapped out this system, and this is going to be a dynamic environment. It's going to change, but your dependencies are there. What you then need to do is where they're occurring. So where are those failures coming from? Once we actually understand specifically where that failure is, I said, that's when I can instigate my mitigation plan. I know it's here. This is a fault domain where the problem is coming from. This is our mitigation. This is our playbook. This is our run book for that particular situation. It may even be that actually feeds an automated process. It may well be when we see these conditions take place, what we're going to do is to replace our DNS records because we know that allows us to get back online as quickly as possible. So understanding that allows you to build these automated workflows in place, as well as having these mitigation plans that allow you to maintain business continuity.
So thanks for the deep dive into that outage, Mike. And now let's turn to the overall outage trends. And what have we seen in recent weeks?
So from November the 17th to 23rd, we observed 91 outages globally. This was a 29% decrease where it dropped from 128 the week prior, which was November the 10th to 16th. The second week, November the 24th to 30th, the outages increased by 27%, rising to 116. From a US perspective, the outages decreased to 31 during the week of November the 17th to 23rd, and this was a 30% decrease from the previous week's number of 44. During the week of November 24th to 30th, the US outages increased by 65%, rising to 51. Now, if we take that 2-week period from November the 17th to the 30th, the US actually accounted for 40% of all observed network outages.
We often see a dip in outages during holiday periods. Did that trend continue this year over the recent Thanksgiving season in the US?
It did. So the global network outages decreased 40% from October to November, and that dropped from 701 to 421 outages. Now, if we look at that for the United States, we saw a more pronounced 62% decrease, with outages falling from 404 in October to 153 in November. And this does coincide with that Thanksgiving holiday period. And as a result of that, the United States accounted for 36% of all observed outages, which is compared to 58% in October.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this help ensure you're in the know when a new episode is published, it also helps us to shape the show for you. You can follow us on X and LinkedIn at ThousandEyes, or send questions or feedback to internetreport@thousandeyes.com. Until next time, goodbye.